Okay. Julius asked me a good question. The question was, what is a relationship? So, you're doing your velocity lab. Chris, tell me something that moves. A car. Let's say you have a car moving along. And you're going to measure what? We want to get to the speed. What do we need to measure to get to speed?
Time and distance.
Okay, time and distance. So we line up, let's say, a bunch of people. Or you watch and maybe you make marks on the road or whatever, and you somehow get the time. You measure out the distance and you get the times at these distances. Okay. You would want probably for your lab, you probably want, what do you think? How many points would you like to have? 5, 10? Yeah, more is better. 3 is probably not enough, right? So it'd be nice to have at least 5. 10 would be great. But let's just do 3. So let's say we measure this out, and from where we start, we have 10 meters and 20 meters and 30 meters. Okay? And let's say this takes, let's say 3.2 seconds, and this takes 5.8 seconds, and this takes 9.1 seconds. Okay. And what Julius is asking is, what's the relationship here? So we're going to graph this. This is your data. So you would put your data in a chart like this, and you'd line up your distance, 10, 20, 30, and you'd have your times here, 5.8, 9.1. Okay? Now, multiple ways to find the relationship. You can take a piece of graph paper, and you can say, this is my time, and this is my distance, and you can say 10, 20, 30, yeah?
Why you put the time on the X scale, not on the why don't you change scale?
You mean, why do I put the time here? Well, there's no rule that says you have to put the time here. But we happen to measure velocity in meters per second. So that's what I want by the relationship as well. That's a good question. So if we look at these, we say this is my distances 10 and 20 and 30. And this is 2, 4, 6, 8, 10. And of course you'd have to have this measured out properly and on a proper graph. And you could do this on graph paper, or you could do it on a Google Sheet or a Desmos or whatever, which I can show you how to do. So at 10, we're at about 3.2, so we're in here somewhere. And 20, we're at 5.8, so we're set here somewhere. And 30, we're at 9.1, so we're here somewhere.
Isn't this kind of similar to like the video of someone walking?
Yes, it's exactly the same. And so, am I gonna just link these up? No. What if I draw my line? I'm not gonna do the ruler. I'm just gonna say, what if I draw my line and it goes through like this? And I'm purposely making it miss. What if it doesn't touch any of the points? It's fine. Does that mean that these things are unrelated? So there is a relationship, right? But it doesn't have to do with any of the individual points. It's actually the relationship between distance traveled and time taken. Okay. That's the relationship I want. It's a simple relationship. It's just linear, right? So how are you going to find this relationship? Yeah, you're going to pick a point up here and a point down here, and you're going to find this slope, right? Let's say it doesn't go through right at 0. Let's say it goes through at like -2 or something. And let's say my slope is, well, what would you guess my slope to be? It's about 3, I think, yeah?
3 or 4.
It's close. Let's say you calculate, you guys know how to do this calculation, right?
Yeah.
You count the rise and you count the run.
And you put it over each other.
Yeah. Let's say that my rise is 32 and this is 9, okay? You would say my slope m, my slope, is equal to the rise of 32 over a run of 9. You do that on your calculator. I don't know what that is. What's 32 over 9? 3.6. I don't know what it would be, but let's say it's 3.6. So now you have a slope, and you have a y-intercept of 2. What is my relationship now?
Y equals mx plus b.
Okay, so we start with y equals mx plus b. That's the kind of format of the formula, right? But what is this relationship? We don't want just letters and numbers. We want a relationship between two real things.
D equals 3.6 times t
Good.
plus, oh sorry, minus 2.
Yeah.
Sean's got it. So this is a format of an equation that you learned in math. These two things are related on a, y and x are related on a linear relationship. But this is actual distance traveled in actual time taken. So this allows us to predict the future. If this car continues to drive at the same constant speed, I can say, well, where's it going to be in 2 years? It's probably going to run out of gas, but let's say it's solar powered and it goes forever. You could put in that number of seconds, calculate it out, and know how far you went. And that's the relationship. Yeah? Good? Any other questions?
So the b is the -2, and it's just
Yeah, this is the y-intercept. So it's wherever you cross the y-axis, and m is my slope. The y is whatever variable we put on the y, and the x is whatever variable we put on the t.
And why is it minus 2 and not 0?
Well, in this case, my line went through here.
Oh.
So I have to say it's -2. Now, you would expect, theoretically, that if you're at a constant velocity, you'd expect it to go through 0. But there's some uncertainty in our data, so it's fine to have it slightly off. It's no problem. Good. Good luck.